Yes, ma'am.
Okay.
Yes, ma'am.
So the next assignment is like you have a business with several offices and you want to lease phone lines to connect them up with each other, and the phone company charges different amounts of the money to connect with different pairs of cities. You want to set of lines that connects all your offices with minimum total cost. To solve the problem by suggesting appropriate data structure. So yes, so what you understand from the problem statement is that you have to set up offices in different places. So offices is going to be your nodes or vertices, and the connections you're going to set up, that is for you want to lease phone lines to connect them up. So the connections that you're going to set up between the nodes is going to be your edges. Now you want to select the perfect edge so that the set of lines that connects all your offices is going to be with a minimum total cost. So does anything come into mind that they are asking you to solve the problem by suggesting appropriate data structure? So what do you feel? Have you understood the problem statement? So problem statement क्या है? Different offices है, which is going to represent the nodes or yeah, vertices, and it's going to be connected together with phone lines. But the phone lines has to be selected in such a way that, because different companies are offering different connections with different charges, so you have to select the perfect edge which will have minimum cost, so that the total cost which is going to be bared by the office is going to be minimum. That is the meaning of the problem statement. So, and when we implement it, we have to find an appropriate data structure for that. So, any idea how are you going to set up this? Hmm? Yes, students?
Minimum spanning tree.
Yeah. So we'll be following the minimum spanning tree procedure. Now, for those who don't remember that, we'll just revise a little bit about that first. First, we will talk about the greedy algorithm part. If you all remember, what is the greedy algorithm? Like you, if you can see the screen, the greedy strategy is that you have many solutions. So you are going to select the best solution at that point of time, what you feel is the best. So that is the greedy strategy. So a greedy algorithm always makes a choice that seems to be best at the moment. Why do we do that? So that we get at the end, when you complete the problem, you get a better or the best solutions. So using that greedy strategy, one of the method is that we have learned is the minimum spanning tree example. So now what is a minimum spanning tree? So minimum spanning tree follows the greedy strategy. That is, you select the best possible or feasible solution at that moment of time. अभी बहुत सारे solutions है हमारे सामने, but कौन सा सबसे best है अब इस वक्त में वो हम select करेंगे. क्यों? ताकि at the end of the when you complete the problem आपको सबसे best result मिले. So these are all, you know, assumptions, and we are going to use an example, that is minimum spanning tree. Now what is a minimum spanning tree? Like you can see a normal graph in the left side and a spanning tree graph on the right side. तो minimum spanning tree का एक condition क्या है कि we need all the vertices to be there in the spanning tree, but the edges will be selected as per the minimum weight. So as you can see here weight is not given, but you see all the edges, all the vertices have already come. So that is a spanning tree. Whereas in the first case, you see a normal graph. So that means a spanning tree won't get closed. Okay. So that is what you have to remember in your mind. So a spanning tree is a subgraph of an undirected connected graph. Undirected मतलब direction नहीं है उसमें, which includes all vertices. That is the important point that you have to remember. It includes all the vertices of the graph with minimum possible number of edges. So minimum possible number Q, so that you can reduce the cost. So if the vertex is mixed, then it is not a spanning tree. So you can see an example here. A, B, C, D, all the vertices have been included. So that is the concept here. Now you can see if it is now in our problem statement, they're talking about a weighted graph. क्यों weighted graph है? क्योंकि A, B, C, D are offices. The edges are the phone lines that has to be connected, and the values written on the line edges are going to be the cost offered by the phone companies. So you have to select the edges in such a way that all the vertices should be present, but the edges will be selected which so in a minimum manner, so that the total cost bared by us will be less. So a minimum spanning tree is a spanning tree in which the sum of the weight of edges is as minimum as possible. अभी यहाँ दे सकते ए बी सी डी सब वर्टिसेस है, बट हमने H5 जोड़ा क्यों? बिकॉज बाकी सब edges use करने के बाद you can see all the vertices have been included, so you can ignore 5 edge. And this is an example of a minimum spanning tree. That means you select edges based on the minimum value. Have you understood the MST concept or the minimum spanning tree concept? Yes, students, समझ में आया क्या?
Yes, ma'am.
Okay, so an example algorithm under the minimum spanning tree which we learned was the Prim's algorithm. So Judge, we shall go through it. So what is a Prim's algorithm? So Prim's algorithm is a minimum spanning tree algorithm. So we know that a minimum spanning tree follows the greedy strategy, and you know what is a minimum spanning tree algorithm. So Prim's algorithm is a minimum spanning tree algorithm that takes a graph as input, finds a subset of edges of that particular graph in the form of a tree which includes every vertex and has the minimum sum of weight. So that is our solution to our problem statement. क्यों? Because हमें all the vertices तो include करना ही है. We are setting up the offices and connections देना है between the offices in such a way that we bear the minimum cost. So Prim's algorithm is the best example we can take to set up our data structure. So just go through it. So it falls under the class of algorithms called greedy algorithms. And what does a greedy algorithm do? It helps you to find the local optimum or the local feasible solution in hope to find the global best solution. So that is what it means, local optimum in hopes of finding a local optimum in hopes of finding a global optimum. So just go through it, see if you've understood, and we'll see an example. Prim's algorithm का theoretical concept समझ में आया क्या सबको? Is it clear? Yes, students.
Yes, ma'am.
Okay.
Yes, ma'am.
So now we'll see an example here. The algorithm, yes. So what you're going to do in the algorithm is you're going to randomly choose any vertex. So you're going to select any vertex, and the vertex connecting to the edge having the least weight is usually selected. Okay, so sometimes you might have multiple edges and you might be forced to select a greater value if the graph results in a cycle or something like that. So mostly and most probably we'll be selecting the least weight edge to choose a edge between different edges available. And if many edges are having the same weight, you randomly select one. Okay. And step 2, find all the edges that connect the tree to a new vertices and find the least weight edge among those edges and then include it in the existing tree. If the including that edge creates a cycle, then reject that edge and look for the next least weight edge. And you do this step repeatedly until all the vertices are included. And the thing we have to keep in mind is it should not result, in a loop. Okay, so it should not be closed. Okay, so that is what we have to keep in mind. So this is an example we can see here. Okay, you're starting, you have a graph here, you can see it's a weighted graph. Why? Because you have vertices and the edges connected with the help of some weight value or cost which is specified at the edges. Okay, now you have to select any vertex randomly as your starting vertex. So as you can see in the image, it's one particular vertex is selected as the starting vertex. So that is going to be your first node or the first vertex that is being selected. Next, from that vertex, you have to see what are the different edges going to the next vertex. So you have 4 and 2. So here, which will be selected? The minimum, as I told you, the best feasible or the best local optimum is going to be selected. So 4 and 2 say 2 select here. You can see the next node is selected with path length 2. And so now we have included 2 vertices. Now to include the third vertex, from the second you have 3 different edges to different offices. You can say 3, 4 and 2. So they have selected 2. So you can see the 3 vertices have been included now. And now the path length has become, what is the path length now? Can you all see the screen?
4.
4, yes. Next, now we have reached the third vertex. Now from that vertex you can see there are edges. So there is only one edge that is possible, 3. So you're going to select that edge 3 and you get the fourth vertex. So by now the path in this 2 plus 2 plus 3, which gives you 7. Clear? Now you have reached this particular vertex. Now to select the next vertex, you have 4 and 3. If you want to go in that way also you can go, unless and until it doesn't form a cycle. So you have to be careful that it doesn't form a cycle. Or like the example what they have done, instead of selecting that, they have taken another vertex and selected 3. So now you might ask why? Because it doesn't make a difference. You can see the weight of 2 edges are 3 and 3. So it's optional which edge you want to select. So they have selected the other way around, and yet now you can see the path length will be what? 7 and 3, right? Yes, right? So,
Yes.
so 7 and 3, that gives you 10. And then you have one more vertex that is remaining at the left corner. So you connect that with 4 because only one option is available. So 10 plus 4 gives you 14. So that's how you get a Prim's algorithm. So please go through this example and see if you've understood. So this is how our example is going to work. Just see if you have understood. Is it clear? Everybody? समझ में आया क्या
Yes, ma'am.
सबको?
Yes, ma'am.
Yes, ma'am. Okay. So, what are we trying to do? We are trying to select we are going to select all the edges which is available in that particular vertex and select the minimum edge and include it in our new connection unless and until it doesn't make a loop. So it should not be already visited. So if it is already visited, what happens? Then it will results in a loop. So you will have to put a flag when you do a code to see if we have already visited that vertex or not. So and we'll be calculating the path length. So this is the theoretical thing. So like for every problem statement given to you, you have to know the basic concepts behind every problem statement. जैसे अभी ये program के लिए हमें 3 चीजें पता होना चाहिए. What is greedy strategy? What is a minimum spanning tree? And what example how a Prim's algorithm works, which is an example of minimum spanning tree. Now, can you tell me another example of a minimum spanning tree which we have learned in our class? Any other example? हमने दो
Kruskal's algorithm.
Yeah, we had learned Kruskal's algorithm. So, since in the problem statement they haven't specified anything, it's your choice. If you want to use Prims, you can use Prims. Otherwise, you can use Kruskal. So, the example which I am going to show you is going to be Prim's algorithm. Okay. Yes. So, coming back to the problem statement, you can see here. This I've already explained what is our aim. So we have a business with several offices and we want to connect them with phone lines, and the different companies that is giving services are giving you different cost. So it is your aim to select the connections with minimum total cost so that you get a minimum total cost. So that say becomes an application of Prim's algorithm or minimum spanning tree. So the objective here will be we have learned what is a spanning tree and a greedy algorithm, and now we'll identify the minimum distance between the vertices of the graph in the data structure. Now, what is a greedy algorithm? We have already seen it, just going through the lab manual. At each step, the best possible choice is taken, and after that only the sub-problem is solved. Greedy algorithm might be depending on many choices. It cannot be depending upon any choices of the future or neither on the sub-problem solution. So why are they saying that? We are actually thinking about the local optimum, then we are not thinking about the next step, what is going to happen in the next step. So only the local, whatever is the local condition or whatever is the local solutions available, you are going to select the best among them. Okay, the method of greedy algorithm starts with the top and goes down, creating greedy choices in series and reduce each of the given problem to smaller ones. So that is the technique. Now, what is minimum spanning tree? It's a kind of subgraph of an undirected graph in which subgraph spans or includes all the nodes with a minimum total edge weight. Okay, so that is what is MST that we have already seen. Then, yes, the Prim's algorithm properties are being given. That is, the edges are subset of some minimums always form a single tree, and the tree grows until it includes all the vertices, and the edge is added to the tree at every step if its weight is minimum. So that is what we are going to consider here. So yes, you have to specify a vertex from where you're going to start the traversal or how you're going to build the tree. So that you have to explicitly give in your code, and then you add it to the tree and find the edge that connects to that vertex which is not in the tree because we don't want it to form cycles. Okay, so now you can see the code here. Here I'm not opening any other IDE or Eclipse right now because right now the system is hanging. So just go through the code which is in the document. We'll see how it is done. So what we are going to do, we are going to input the values first into the graph, and then you will display the graph but as an adjacent matrix or an adjacent list. It depends on your choice. So and based on that you're going to find the minimum cost. So we need 3 functions: input function, display function, and a minimum function. Okay, so far clear? Have you all understood what are the 3 functionalities we require here? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, so and we are going to represent it in the form of a matrix. That is why A2020 is being declared here. So we are using adjacency matrix. Now, if you want to use an adjacency list, also it's very well and fine. Okay, in this example, we are using adjacency matrix. So because we have to represent the graph, and then using that representation, you're going to, select the minimum cost tree. Okay, so now, yes, the class name is tree. So here we are defining the function input of the class tree. So what are we doing is we are entering the number of branches. So branches here means number of offices. So they are, you are setting up the business. So you have to enter how many offices you are going to set up. So enter the number of branches or offices that is being taken, and you are assigning the visited flag of each vertex as 0. Okay, like you can see, if we visited I is equal to 0 is being assigned. So the visited flag is set to 0 for each vertex, and you can see the matrix is initialized to 999. Okay, because if a particular vertex is not connected to another vertex, suppose a vertex is not connected to another vertex, the value that is going to be stored in the matrix is going to be infinity. And to represent infinity here, that is 999. So the matrix is right now filled with 999. And what else? The flag of each vertex is set to 0. So that is what this particular set of statement means. So have you understood so far? What are we doing? We are entering the number of offices, and for each office you are making the flag as 0. And for now, you know how adjacency matrix look like. So depending on the number of offices, that many rows and that many columns will be there. And so for each value or index of the matrix, we are initializing it to 999. Clear? Understood the statements of the code? Is it clear?
Yes, ma'am.
Okay, just tell me when you don't understand. Huh? Then enter the number of connections. So what is it representing? Can somebody tell me what is that going to represent? Enter the number of connections. Can somebody tell me वो क्या होगा? We are taken the enter the number of branches first. Now what is the enter the number of connections? वो क्या हो? What is it referring to?
Number of edges.
Yes. So it is referring to the number of edges. So we have set up the offices. Now we need to see how many edges is going to be there for the graph. So right now we are not doing the minimum spanning tree. We are first setting up the graph. So enter the number of edges. So how many edges are possible, or how many edges a graph is going to have is going to be given here. Then after that, in this loop, as per the number of edges, you are entering the end branches of connection. मतलब आप बोल रहे कि edges, there are 7 edges, but ये edges कहाँ पे है? कौन से vertex के बीच में है? So that is what this particular statement is saying. Enter the end branches of connections. So it is saying, can you all hear me?
Yes, ma'am.
Yes, ma'am.
Okay. So enter the end branches of connection means you are entering the vertices between which the edges will be there. So enter the end branches of connection L and U. So L and U are the two vertices between which this one particular edge is going to be there. So I is equal to 0, I less than the edge, I plus plus. So based on that, I told there are 7 edges. Suppose I told you there are 7 edges. I should specify कि ये edges कौन से vertices के बीच में हैं. Okay. Next is after doing that, enter the phone company charges for this connection. That means it's a weighted graph. So for each edges, there will be a cost. So you have to enter the cost of it. So have you understood these four lines now? Is it clear to everybody?
Yes, ma'am.
Okay. Now, what do you feel in this particular line, which I have highlighted here? What do you feel? What is it about? Can somebody tell me any idea? ये जो लाइन है इससे कुछ समझ में आ रहे है क्या किसी
It is
को?
an undirected graph.
Yeah, it is an undirected graph. So मतलब क्या है? If like I'm just writing it here, I'll delete it later. So what does that mean is if Aij is equal to Aj and both is going to have the same weight. समझ में आया? Is it clear? So that is the meaning of this particular statement. That means since it's an undirected graph, you're going to take the edge as bidirectional. So if it, when you say it's bidirectional, in both ways, like if you take it from I to J or J to I, the weight is going to be the same. Is it clear?
Ma'am, why have we written L minus 1 and U minus 1?
Because we are going to start the values from 0, right? है ना?
Yes, ma'am.
L का वैल्यू आपने 5 किया मतलब अरे का इंडेक्स 0 to 4 होगा ना इसलिए.
हाँ. Okay.
Got it?
Yes.
Okay. So yes, so that is what that particular statement meant. Now next, so we have done, we have taken all the input. So सबको input function समझ में आया है क्या? Tree का input. What are the inputs we have taken? We have taken the number of branches. We have assigned the flag to 0, visitor flag to 0, and matrix हमने 999 से initialize किया है. Then we took the number of edges and based on the number of edges we have also entered ये जो particular edge है वो कौन से vertex के बीच में है and वो edge का cost क्या है and accordingly we have set the weight for bidirectionally. Is it clear to everybody? इनपुट समझ में आया क्या सबको? इनपुट फंक्शन.
Yes, ma'am.
ओके. नेक्स्ट इज डिस्प्ले. नाउ डिस्प्ले में क्या हो रहा है? एडजेसेंसी मैट्रिक्स तो रेडी है तो you just have to call the you are going to just print the matrix. So you're just printing the adjacency matrix. You can see you need for loop and to print it in the matrix format accordingly you have put C out and you will get the matrix as the output. So graph is going represented here as an adjacency matrix. तो आपको चाहिए तो you can represent it as an adjacency list also. Clear? Yes. Next is now finding the minimum spanning tree. Now the algorithm works here. So if you all remember the algorithm, we can see what is being done here. Okay, minimum. So once you are starting with the first node. So now they have taken visited 0 equal to 1. So we are going to start with node 0 here first. Okay. So instead of asking the user to enter a node, we are going to start with the first node 0. So they have taken visited 0, 1. And now have to, you have to do this process until you have reached all the vertices. Okay. If all the vertices are covered, then you will stop the process. That is why count equal to 0, count less than or equal to b minus 1 and no less than b minus 1 count plus plus because we are only going till the vertices. Our aim is only to cover all the vertices. You are not bothered about the edges. So that is why the loop is given in that way. And the minimum value we have assigned here we have assigned the adjacency matrix with the value 999. So MIN is taken as 999. Then once for each vertex visited, you will set the vertex visited flag as 1. And if it, then you traverse the remaining vertex, right? For how do you traverse it? If that vertex is not visited and its value is, you can see if minimum is greater than a of ij, मतलब क्या है, अगर जो you are selecting another vertex, okay, from the current vertex you are selecting another vertex and that vertex is not visited till now and its weight is less than the minimum value, then you will put that as the minimum value and you will search. So why are we doing this this statement? This statement is to find the best edge among the vertices which is not selected, so that you can add it to the graph, minimum graph. Okay. Yes, so that's how. And once you select it, you get the p value and the I value. And the p value and I value, p and not p value and I value, p and q value. And that p and q value of visited flag is set to 1. And that minimum value which you obtain or the minimum edge which you have selected after checking the least value among all the vertices which is not visited, that particular minimum is added to the total. So by the end, when you reach all the, when you have selected all the vertices, what happens? You get the total cost at total. So you will print the minimum cost connection at this particular P vertex to Q vertex is with this charge, and the minimum total cost will be total. So this is how the Prim's algorithm works. So I'll just explain it once again. What are we doing here? We are starting from the 0 index. You're setting that as visited and you are initializing minimum as 999 because that is a value which we have initialized with the in the matrix, and it's normally in when you do theoretical you say infinity, so that's why minimum is equal to 999. And how many times you're going to perform the loop? Until you have covered all the vertices. So you are putting the loop as per the count of vertices. And now when you select one vertex, you make it visited as 1. See, if the visited is 1, that is the vertex which you have selected, then you traverse for the next vertices in such that the visited is not equal to 1, and you find out if the minimum value right now is greater than the minimum value of the selected vertex. If so, you put that as a minimum value and you set the end vertices as P and Q, which is going to get the value I and J. So this process will continue until all the vertices have been selected, which has the minimum cost. And at the end, when you select a particular vertex, what is happening? You are going to set that vertex as visited 1. So you're setting vertex P as 1 and Q as 1. And whatever minimum value you have got at that point of time is added to the total cost so that you can get the total minimum cost at the end. So that's how the Prim's algorithm works. Is it clear to all? Have you all understood the minimum function? Is it clear? Yes? Students, are you all there? Have you all understood the minimum function?
Yes. Yes, ma'am.
Okay. Okay, next is in the main function, you are going to create an object of the tree. And yes, according to the choice, like if you want to input the value, you will press 1. If not, if you want to display, you will press 2. And if you want to find the minimum cost, you will press 3. So based on that, a switch statement is used. You can see if it is input, it's you're calling object dot the function input. If it is display, you're calling object dot the display function. And if it is minimum you want to find, you're calling object dot minimum function. So this is how your output will look like. So you're getting the output like this: input, display, and minimum. So since we don't have any input, we'll first input our choices. Sorry. The and number of branches is 6 here, and number of connections is 8. So I have taken the same example we saw here. Okay. So we have 6 vertices here. I'm sorry. You have how many? 1, 2, 3, 4, 5. Yeah. You have 6 vertices here and 8 connections here. So based on that, enter the number of branches 6 and enter the number of connections 8, and enter the end branches of connection. That means you have to enter where these edges are there. So you can, as you can see, for example, you can number the nodes and you can see like 1 and 2 has a connection. If 1 and 2 has a connection, you will write 1, 2 and enter the phone company charges for the connection, the cost of that branch. 1 and 2 cost has 4. Similarly, you will enter, it will go on asking the same statement until you cover all the 8 connections. You can see this. So you will enter the edges where the particular connection is there and you will enter the cost for that. So once that is done, now again it will ask you, the menu will come again. So now you want to display the matrix. You can see how the matrix is displayed. You can see the place where there is no connection is given as 999, and the places where there is connection, you can see the cost is there. So here it is not 1 and 0. Why? Because it's a weighted graph. So in a weighted graph, the matrix will be wherever there is a connection, the weight of that connection will be put, and in other places it will be either infinity or 0. So you can see here we have put 999 wherever there is no connection. So as if you remember, in the input part, we were initializing the matrix with 999, and whenever a connection is added, you're putting the values over there. So adjacency matrix, you get it like this when you display. And yes, again the menu will be displayed, that is minimum, and you put the choice. Say if you put it as 3, then it will calculate it, and you can see there is a connection from 1 to 2 with a charge 4. So it will print all the connections that is minimum at that particular point is being selected, and you can see the minimum total cost of all branches is 14. So I guess in the same example which we saw here, the path length is 14. So you get it, and this is how the program works. So I hope you've understood how the program is implemented. Any doubts? Yes, students, any
No, ma'am.
doubts? Okay. So now what you all have to do is, yes, I'll be sharing yesterday's link as well as today's link. And please go through the code line by line, execute it and see if you understand, and then upload. Okay. And many of you all are still not uploading, like I am evaluating you all. Again, there are 2 assignments which was taken by Vishal sir and Vishal Bhag sir. I see many of you all have not completed the submission over there. Those who haven't submitted, please do it today itself. Okay, because we are evaluating you all based on the submission. And yes, of course, those who are not feeling well, I can understand, then please drop me a message so that I can record why you have not submitted at that particular point of time. Clear? So any doubts? Any doubts?
We are comparing minimum is greater than a of ij. So like it would be taking only the minimum value every time, like and
Yeah,
adding in the total.
yes. It will only be taking the minimum value. We are not creating a new graph in this particular program. Actually, we are finding the which connections. If you have a graph representation, you are not going to change the graph representation. Instead, we are finding which edges will contribute to the minimum cost. Understood. So in minimum, you're just finding the minimum. And once you find the minimum, you're recording the vertices and the minimum is added to the total. That's it been done. You are not creating a new graph.
Yes, ma'am.
Fine. So anything else? Is it clear?